Qualitative and Quantitative Analysis of White Powders and Clear Liquids, presented by Jennifer Schero, written by Mary Margaret Capraro and Adriana Lundsford. I chose this PVL because it allows students to be problem solvers and use their critical thinking skills to make connections amongst the things that they've learned in chemistry throughout the year. Some of the prior knowledge that students will need to bring to this activity to make it successful are solutions, conductivity, chemical reactions, acid and base properties, physical and chemical properties of pure substances and mixtures, writing conclusions based on evidence and scientific reason. The well-defined outcome: students will determine the composition of a toxicology sample composed of unknown white powders and clear liquids. Based on their findings, students will decide if the toxicology sample could be potentially lethal or harmful to humans or animals. Students will create a professional lab report, journal article, or toxicology report. The ill-defined tasks. Students will use what they know about qualitative and quantitative analysis techniques in chemistry to determine the composition of a toxicology sample, which is composed of a mixture of unknown white powders or clear liquids. Students will be assessed on whether they have correctly identified the components of the unknown mixture and on their analytical process for achieving their results. In this activity, students will conduct a variety of analysis tests to gather data about known white powders and clear liquids. The results of these tests on the known compounds will give students a chance to practice analysis techniques and identify the results for a variety of unknown compounds. The science skills students will use in this activity include using creativity and insight to recognize and describe patterns, designing and constructing scientific investigations, working collaboratively, demonstrating skill in safe and appropriate use of techniques, and using several modes of expression to describe the properties they witness. Students will use the processes and techniques that they've learned throughout the year to analyze their known substances and can be made into a flowchart like this one to help them analyze the components of their unknown mixture and write a valid conclusion. The STEM objectives in this activity involve science, applying properties of chemicals, considering safety and toxicity, and analyzing known compounds; technology, using it to gather information and accurately record and display data; engineering, solving a problem using critical thinking and analytical skills and providing evidence for conclusions; and mathematics, interpreting various data charts and graphs to determine trends. In addition to objectives of science, technology, engineering, and mathematics, chemistry students will use physical and chemical properties to describe and classify matter, classify pure substances and mixtures, identify chemical reactions by type and evidence, discuss the behavior of matter, of solids, liquids, and gases, and apply properties of solutions. Day 1 is all about setting the scenario and engaging the student. In this activity, the State Police Crime Lab has raided a local warehouse and found several large bags of suspicious white powders and clear liquids. Officers know that recent drug overdoses and deaths in the area have been associated with the addition of potentially lethal contaminants to already potentially life-threatening drugs. This video is a great way to set the scene and engage your students. This is a video of the forensic chemist in the Sarasota County Sheriff's Office, and she goes over almost the exact scenario that your kids are going to be doing when they do this activity. Okay, class, today we're going to get our thinking caps on and start thinking about how we're going to do some of our tests on our white powders. Our 3 white powders we're going to look at today are soap and salt and sugar. Before you answer, think about this. what sort of techniques might we be able to use to test our white powders? Okay, now that we've had some time to think, Nikki, could you tell me some tests that you would use to test the white powders?
I would use solubility, density, and pH.
Okay, well tell me, how would you test solubility?
I would place my powder in the water and see how long it took to dissolve.
How would you get it to dissolve?
I could use a stir rod to stir it up and cause it to dissolve faster.
I like to allow students time to think before they answer, as well as to help them with prompting questions. For instance, if I call on a student and they don't know an answer, I like to give them guiding questions like, well, what do you think would happen if you mixed a clear liquid and a white solid? All right, I want you to think again about now. If we're measuring solubility, what equipment or tools might we need to do that? Nikki, why don't you tell me what you have?
I would need a beaker, a hot plate or Bunsen burner. I would need a stir rod and some kind of measurement device. I would like a teaspoon or something.
Before groups move into the laboratory, it is a worthwhile activity to have them share what tests they are going to do on their known substances and have it be a give and take and back and forth, so students who don't know what to do might get an idea of how to get started. As students move to laboratory to begin testing their known compounds, they should make sure that they assign group members to different jobs like procedure and flowchart and materials and following the procedure. Of course, everybody in the group should all be responsible for cleanup. In this video, my daughter Nikki demonstrates solubility testing as a student might do, but in a home laboratory kitchen instead of in a classroom laboratory.
So we've done our solubility tests. The Ajax had made a milky substance with bubbles. The salts dissolved completely and rather quickly, and the sugar isn't quite completely dissolved and sits in a group at the bottom.
Students sometimes forget to look at the reference materials supplied with their activity. For instance, the safety data sheets can be used to determine if the compound they've been given is toxic. They can also use the chemical reactivity guides to understand properties of acid-base reactions, and the probeware can be used to incorporate data like temperature and pH in their laboratory. On day 3, teachers can explain some techniques that students might not have thought of. For instance, reminding the students what an electrolyte is and what it is made of, and how students can test solutions using a conductivity probe for whether or not they are electrolytes. After that, students can move back into lab and continue their analysis. One way to evaluate student progress is to be able to watch them while they work in the laboratory. A good tool to use is this formative assessment rubric on the next page that can be used while you are walking around and observing student work happening as part of this laboratory. A simple rubric like this can be used to assess whether students are recording their procedure steps, recording appropriate qualitative and quantitative data, whether they are constructing their flowchart as they make decisions, and whether they are using academic chemistry vocabulary and working safely and using good laboratory techniques while working together collaboratively. I have found that this sort of rubric is a quick and easy way to give feedback, and will allow your students the opportunity and the motivation to refocus their efforts and make sure everybody is doing their part so that they can get a good group grade, which is always something my students find to be a good motivation. This is a challenging day or two for the students. They will use their flowchart to determine the identity of their unknown mixture, but they will also begin formulating and completing their toxicology report, where they will make the determination, was this a toxic substance that was added to the drugs. On day 4 and 5, students will now put their analytical flowchart to the test, and they will receive their unknown mixture that they will have to test and use their flowchart to make decisions about what it is they actually have. Their mixture could be a liquid and a solid mixed together, could be a solution, or could be two solids mixed together. As with any work in progress, the students' flowcharts might need revision as they go along, and this is totally acceptable and can be encouraged by the teacher with a few good guiding questions. Some good examples of guiding questions are, for instance, once a student knows that a liquid conducts electricity, you might ask them, well, what does that mean? What does it have in it if it conducts electricity? And are there any substances that have those things in it? And what might be the differences between those substances? It's all questions meant to keep the students thinking about what are the next steps. The summative assessment will assess students' scientific processes and whether they designed and conducted a scientific investigation, whether or not they demonstrated safety and technique skills, whether or not they correctly applied writing and communication, and whether or not they documented their scientific investigation by producing a written procedure and written results that were effectively presented. The summative assessment concludes with whether students were able to positively identify their unknown or components of their unknown mixture, and whether students demonstrated extensive chemical knowledge throughout their investigation and their final product. There are many formats your deliverable can take. You could have students do presentations, or like in this case, you could have students produce a poster board that includes the flowcharts they use to make their analysis, their quantitative and qualitative observations, what the basis or scientific reasoning is for their analysis, and whether or not their mixtures are toxic. After determining the composition of their unknown mixture, students should formulate a hypothesis about the likelihood that the substance was used for a criminal act and whether the substance could have led to the death of individuals consuming the contaminated illicit drug. If time permits, students can present their findings to the entire class. Depending upon the level of the class that you teach, your next steps or extensions could be ways in which you make this more complex for the class. For instance, in an upper level class, you might make each group make a unknown mixture so that it can challenge another group to find out the composition. One of the ways that I would change this PBL is I would add a writing experience at the end of this PBL. To do this, students will use a format called Claim Evidence Reasoning that we have been practicing throughout the year, so this should be very familiar to my students. To start their writing, students state a claim, which is a concluding statement that answers the question put forth by the investigation. In this case, students will answer what are the identities of their unknown substances within the mixture, and are these substances toxic to humans or animals. Next, students will use evidence from their investigation to support their claim. This is a summary of the actual qualitative and quantitative data or trends that they observed while they were tested. In the final portion of the writing, the reasoning is used to connect the scientific understandings that explain how and why the evidence supports the claim. Students will use their flowchart that they have constructed and explain how they analytically decided what the identity of their unknown mixture was. It could have one component or more than one component to be explained. Students can add to this final conclusion by proposing some next steps that they would like to study as a result of having done this laboratory. I have to say that this type of concluding format works really well once students get used to this format and can apply it. Here is a list of the resources that I use to add content and creativity to this presentation. Thank you for watching, and I would appreciate any feedback you have.